Hi. So the third learning objective in section 3.1 is to explain why measurements must be reported to the correct number of significant figures. And significant figures are going to be a big part of class this year. Basically, every time you answer a mathematical question in chemistry, there's going to be a correct number of digits you should use and an incorrect number, and you need to know the correct number. And why is that? Usually that's not something that is emphasized all that much in math class. If you did a calculation in math class, and let's say the answer on your calculator, was something like 3.789524, and you just said 3.8, usually math teacher knows you did the calculation correctly, that's fine. The difference is that in chemistry, numbers stand for measurements. And the number of digits a measurement has is very much related to how good the instrument was to use to make that measurement. If you look at the example of the width of this door here, you can see the width of this door is made with three different rulers. And the first ruler only has markings for every 1 meter, 2 meters. So of course we can go one digit beyond the smallest marking, and that's how we get 0.8. But look at this last ruler. It has markings for every individual, looks like, not just 1/10 of a meter, but 100th of a meter. So we can go one digit beyond that. That's how we get that number. So how many digits a number has is an indication of the instrument that was used to make it. So that's what significant figures are. The word significant figures, we're going to be talking about this a lot this year. When we use the word significant in significant figures, it's not the English use of that word, which means important. All digits are important in some way or another. What a significant figure means, it means that was measured. That was not simply placed there as a placeholder. So there's a certain number of rules, and we're going to go through those rules right now. Rule number 1 is that every non-zero digit in a reported measurement is assumed to be significant. And again, significant means measured, which means that 24.7 meters, yep, all of those are significant. And I'm just going to put a little check mark over the significant digits. 345.3 seconds, yes, that means that the stopwatch that I was using could read to a 1/10 of a second. 9.33 liters, that means the instrument that was using, a graduated cylinder or something else, could read down to a 100th, right? The smallest markings were a 1/10 of a liter, and then I estimated beyond that to the 100th. Now, zeros are where it gets tricky. So zeros are really the only, every digit that is either 1 through 9 or 0. Zeros are the tricky ones. When they are between non-zero digits, they are significant, sandwiched sometimes, or in the middle. There's many ways to talk about this. But if you see, okay, of course, 7 and 4 are significant. These zeros are in between, which means both of those are also significant. There's no way I could have read that it was 7,004 meters without those zeros actually being measured as well, right? 9.02 seconds, that zero was measured. 1.403 liters, those are all significant. So middle zeros, always. And then we get leftmost zeros. Leftmost zeros are beginning zeros. That's often how I use them. They are not significant. And another way that you can think of it is if you could leave it out for scientific notation, then it's not significant, right? And so if I look at this, these are beginning zeros. When you start from the left, anytime that you have zeros, and it's not just one, it's all of them, right? Those are not significant. If I was to add a little bit more on this balance, so kilograms, that would mean it would measure mass, it would go up to 0.00039, right? Those zeros wouldn't change. So that what we mean by that is that they're placeholders, right? If they are significant, in the American, like the everyday word of talking about it. They're very much important in that if I leave them out, it changes it drastically. You know, instead of 0.0082, if I just said 0.082 or 0.82, that changes the number. So it's not that they're not important, it's that they weren't measured with the instrument that I was using quite yet, right? I take this number and I put it into scientific notation. It becomes 8.2 times 10 to the negative 3. See how those beginning zeros fell away? They're not significant. Zeros at the end are where you get some ambiguity. You have to look at whether or not there is a decimal point there. So remember, middle always, beginning never, and end is sometimes. It always has to do with whether there is a decimal point anywhere in the problem. So if I look at, of course, 4 is significant. These zeros, are they at the beginning? Nope. Are they in the middle? Nope. They're at the end. And then once you decide that they're at the end, then you look, is there a decimal point in the problem? There is. So these are significant. They were measured. The next number on this, what would it be, like a ruler, would be 4.01. See how that number changed? That means it was significant, right? The 2 and the 3, of course, are significant. The 0 is at the end, and there's a decimal point. These zeros are at the end, but there's a decimal point. So guess when they're not significant? When there's no decimal point, right? So 3, these zeros are not significant. Again, it doesn't mean that they're not important. 300 without those zeros is just 3. What this is telling us is what was the instrument used to make that measurement? Because this is telling me that the next measurement on, let's say it's a stopwatch, would have been 400 seconds. Those zeros are not measured. They're there as placeholders to make that 3 stand for 300. Again, zeros at the end, but there's no decimal place. Zeros at the end, there is no decimal place. No decimal point, I should say. So it's all about where they are. So the first thing you look at is where is the 0, beginning, middle, end. And after you do that, then you look at, is there a decimal point or is there not a decimal point? There's a few more other rules that we're going to use all the time. And the first one is measurements with unlimited numbers of significant figures. So those are things that actually weren't measured. There was no instrument used. So when we talk about, well, there's 12 eggs, I counted the 12 eggs. There was no instrument that I used to measure it. It's just plain, it has an infinite number, unlimited number. And the other way that you can have an unlimited number of significant figures is when they are quantities that were defined, right? We define 1 hour is 60 minutes, exactly 60 minutes. So when we go to make our calculations, we can use those as having an infinite number of significant figures.